Hello there, I will not hold back. The NavMesh module in Unity is a scam, but we are still going to use it. By the end of the video, you will be able to make your enemies smarter. You will get a few free assets along the way, along with some extra learning resources. And there is also a challenge for those who really want to get better at making games. So make sure you stay until the very end. NavMesh is part of UnityEngine.ai package. AI stands for, you know what it stands for. You instinctively think, great, I will build an AI for my game. No, there is nothing AI about the NavMesh system. It just helps an agent find the shortest path to the destination. We will work on two problems today. First, we learn how to use the NavMesh system to make a stupid enemy. The enemy runs straight to the player and shoots at him. Second, we make the enemy smarter. There you will learn a few techniques about what it takes to make smart enemies. Also, you can expect quite some work with animators. Let's start by creating a new project. I will use a universal render pipeline 3D template. Now we need an environment. Think about it very hard. Then snap your fingers and there you go. Okay, that was a bit fast. Well, here's a gift for you. I've published this 3D sci-fi kit on my website. You can go grab it for free. It has a few basic walls, floor tiles, corners, ceilings, and even a super cool dummy bean, which we'll use as target practice. The models are available as FBX, and there's a bonus Unity package that you can import to get started quickly. It's the first version, and I will add more and more objects along the way and over time, probably with each release of a new tutorial. Alright, to fill this area out, I will use some prototyping boxes. I'll place a few around to create some kind of interesting layout, and to keep them snapping to the grid, just hold Ctrl or Command while moving them. And to keep things clean, I will group them all in a new game object called boxes. Once your environment is ready, and it really does not need to be that fancy in the beginning, we can bake the NavMesh. Go to Windows, AI, Navigation. There you can tweak a few settings about how the NavMesh will be baked. For our agent, to find the shortest path to the destination, it must know where he can walk and where he can't. That's the purpose of baking. You can set the radius, height, step height, and maximum slope for each type of agent. You can also define areas and give them different weights or penalties, so the agent might favor one path over the other. You can imagine giving water more weight than the normal road. So when the agent computes the shortest path, that weight will influence the result. To get started, the default values are totally fine. The process of baking is highly complex. Click on Bake and you are done. Everything that is blue is navigationable. Navigationable? If it's blue, it's good. Parameters like the radius will determine the border around obstacles. Now, how did Unity know that those are obstacles? Because they have been marked as static. The dummy bean is not static, so it is getting ignored. To be more precise, the complete object does not need to be static. It just needs to have the navigation static checked. If you change the environment, you have to rebake the NavMesh. And once you will work with large scenes, you will love the NavMesh system, I guarantee it. For now, that's enough bakery. Let's set up our agent. Creating characters takes a lot of time, so we are going to go asset fishing on the Unity Asset Store. Luckily, I found this gem, a robot hero fully animated. It even has 3 variants from low to mid to high poly. It's great, this will work very nicely for what we are doing. Once imported in Unity, you will have the sci-fi warrior blah 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 folder. It has all that you can expect: meshes, materials, animations, a demo scene, and the prefabs. They all work the same, so choose one you like. I will go for the PBR character one. Drag and drop, and that's it. There is one animator set up for us. Just hit play and you can get a nice demonstration of all the animations inside that package. There's shooting, reloading, ducking, jumping, and so on. We'll just need a few of them for what we are doing. Alright, time to set up this guy. First, to use the NavMesh that we baked, we need to make this a NavMesh agent. Add component, NavMesh agent. I won't go over all the parameters, otherwise we'll be there until next week. What you should remember is that the agent can't move and turn by itself. And here you can tweak that behavior. We see that the radius and height fit pretty nicely, so we're going to leave it as it is. However, we are going to change two things. First, we set the angular speed to 200, so the character turns faster. And since it is a shooter, we will set the stopping distance to 8. This means that if we tell it, go to this cool dummy bean, it will go there, stop 8 units before. Now this guy needs to shoot, so we need to get a reference to the gun barrel somehow. This is where the bullet comes out, at least visually. This next part does not feel 100% right. It's probably the main disadvantage of this asset, so bear with me. There is the assault rifle, but when you play it stays at the same position. But the mesh moves, because it is a skinned mesh renderer. I couldn't really attach anything to it. So we have to go down the rig, open the hips, spine, shoulder left, upper arm left, lower arm left, hand left, and finally index proximal left. Phew! Let's create a new game object as a child, name it gunpoint, and give it a nice label. Now here's the ugly part. Set the position to -8.3, 1.3, and 77.5, seriously. If you play, you see that it looks kind of okay. We can live with that for now. Remember, characters take a lot of time to make. Okay, out of play mode, and let's prepare the animator. There are tons of ways to work with animators. In a few minutes, I will share a very interesting talk about animating with Unity. Alright, we will do the movement with a blend tree. Right click, create state, blend tree. Rename it to movement, and right click on it again to set it as a default state. Double click on it to open, and there is our blend tree that doesn't blend much yet. It automatically created a parameter which we will rename to speed. A blend tree is pretty simple. Given some values, it will blend between multiple animations. Click on it and let's add two motion fields. The first animation will be idle guard and the second one will be run guard. The speed parameter controls how much of each animation is used. 0 means idle, 1 means run in this case. And everything in between is a blend between both animations. It's a very natural way to implement movement. Let's go back to the base layer and add a shooting animation. I will copy and paste the shoot burst AR state and add a transition in and out. Now we need another parameter which will be a bool called shooting. We transition from movement to shoot when shooting is true and come back when shooting is false. Alright, that's all we need for the first version. Yes, there will be a second version, a better one. Hey, are you enjoying this? Consider subscribing because many more tutorials are on the way. Otherwise, the bean gets it. Let's make this agent alive. Create a new script, enemy brain stupid. Yeah, I really named it like that because that way of doing an enemy is too basic, but we have to learn it once. And let's create another script called enemy references. That script will hold all the references so that any script on the enemy only need to reference that one object. You can save a lot of repetitions that way. Let me show you. We will need a reference to the NavMesh agent. For that, we import unityai.ai at the top. In the awake method, we use getComponent to get the NavMesh agent on this object. We also need the animator, so we do the same thing. Now, they are public because other classes will use them. So if we want that they don't show up in the inspector, we can add in brackets hide in inspector. I also add disallow multiple component on the class, so we can't have more than one per object. Let's move on to the brain. The enemy needs a target. It will be the cool dummy bean, but could also be something else, and we just need the transform to get started. Let's keep it simple in this video and we will set the reference manually in the inspector. We will not implement a full targeting system. Next, we will take the enemy references, which will be private because we can do a get component in the awake method. Now the enemy will do three things. 1, run to the target. In this case, the NavMesh will do the movement and turning. 2, look at the target when you are not moving, so we always aim at the target. And 3, finally, shoot. It's not a very smart enemy, I told you, but it's going to get better after that. The code base works like this. If we have a target, we compute the distance between us and the target. If it's smaller than the shooting distance, then we look or aim at the target. Otherwise, we update the NavMesh. We can take the shooting distance from the NavMesh agent .stopping distance that we set at 8 before. And as for the NavMesh agent, we simply get it through the enemy references object. Are you ready for some quaternions? Of course you are. So we subtract the target position from our position and set y to 0 to ignore it. That gives us a direction vector. Quaternion.lookRotation converts the direction to a rotation. And finally, instead of instantly turning, we can slurp to smoothly turn from our rotation to the computed look rotation in 0.2 seconds. For updating the path, I will show you the better way already that is skipped in most tutorials. On the NavMesh agent, you call setDestination on it and it will compute the shortest path and start moving there. This is something that you should not do every frame. You don't need to compute the path every frame. So we are going to add a path update delay in our enemy references. By default, we will update the destination every 0.2 seconds. Next, we track when we can update the path with a private float path update deadline in the brain script. Finally, we can write the update path method. First, we check if we passed the deadline. If yes, we set the new deadline to time.time plus enemy references.path update delay, and then we set the destination. It's time to add those scripts onto the enemy and test. Let's just set the target as our cool bean and play. Alright, it works. It follows the target, stops at 8 units of distance, and below that range rotates to always face the player. Now what's left for that part is to hook up the animation. To do that, we can simply set the speed on the animator to the NavMesh agent.desiredVelocity.square magnitude, for example. And for shooting, we set the bool to the value of in range. Alright, looks much more alive now. A highly motivated but very stupid enemy. You can move the bean around and look at how the agent and the animator reacts. It works, but we can do better. But before we move on to the smart stuff, let's just implement the shooting. And you know what? We are developers, we love reinventing the wheel, but we are also lazy. So let's just borrow that shooting from somewhere else. Liam Academy has a great tutorial for shooting with a raycast and have a visual feedback of the bullet traveling the distance. So thank you very much, I will take that. Let's start by creating our enemy shooter script and dropping it on the enemy. Now what's special here is that we will let the animation do the shooting. If you open up the animator and find the shooting animation used by the shoot burst state, you can also directly find it in the animation folder, then into the animation tab and finally scroll down to the event section. Here I've added 3 events that we will call the function shoot. Just click on this little icon and it will create one. I've placed those events carefully where the animation shoots and right before the recoil starts. When this animation plays, those events will call that method on the object where the animator is. Our animator is on the same object as our shooter script, so that will work. Once you add your events, just make sure you hit apply before continuing. Let's now write some code. We need a few new references that are unique to this script. Transform shoot point will be from where we shoot the raycast. That will actually be the center of the character because I have no idea how the gun is animated and where it points. Transform gun point is where the gun barrel ends and we will use that just for the visual effects. Then, who says raycast says layer mask, of course. In Liam's tutorial, he also implemented a bullet spread, which is really cool and not much work. So we will do the same. Then we need a reference to a trail renderer, and finally we keep our trusted enemy resources that we will grab in the awake method. Next, let's define the method called shoot, and inside we start by getting the direction to shoot. Then we do a raycast starting from the shoot point. This line of code will draw a debug line that will stay 1 second. This is super helpful to debug the raycast. And finally we create a new trail renderer and send it to the coroutine that we are going to define in a second. Let's go over get direction first. It's fairly simple. It takes a forward vector of the character, adds a random spread on each axis and returns the normalized vector. The coroutine is basically moving the trail renderer along the raycast over a certain amount of time. Since it is a trail, it will naturally fade away. Still, we destroy it at the end. Now spawning trails like this, that is really not efficient, and if you want to use this in production, just check how object pooling works, it's much better. Object pooling is a keyword, so if you want to build something a bit more serious or a bit bigger, just check how it works, and it's available in the latest version of Unity. It's very easy to use, just use that. Back to the editor, we dragged the script earlier, so we just have to hook up the references. The gun point into the gun point, and for the shoot point, we could take the spine, for example. That worked well for this character. And for the layer mask, let's just set it to everything for testing. Later we can change that to just be on the environment and other characters. And finally, let's drag the bullet trail prefab into the last slot. This is given as a bonus in the free sci-fi package. You can easily create your own as well. It's just a trail renderer with a curve that starts relatively small and fades to 0. The time is set at 0.2 seconds, and the color is a gradient that goes from orange to a darker orange but fully transparent. Another detail is that the default material was not looking so nice, so I duplicated it and just changed the color mode from multiply to additive. Alright, let's not forget to save, hit play, and let's enjoy how our cool dummy beans gets shot at. So you see the rays going from the spine, but the visual effects goes from the gun. That's how you easily can get accurate shooting, but with a believable visual. That's our stupid enemy. I say stupid because it goes straight to the target, shoots him in the face. It's very boring behavior, very boring. Now, to make the enemy smarter, we have to take a step back and prepare the terrain, so to say. Right now, we have a change in behavior using one simple Boolean check. Beginner mistake would be to add more Booleans and more conditions to support more features. No, we need to basically use another code structure that will allow us to move forward more easily. We can use a simple yet powerful solution, which you've certainly heard of: finite-state machines. Finite-state machines are simple. You have states, a finite number of them, so you know all the states, and you have transitions from one state to another state. There are no more rules than that. You can organize your states and transitions as you please. The Animator is a state machine as well. Small side notes. Making so-called AI in video games is a big and complex subject. In this video, we explore finite state machines, but there are also other techniques that you can use. And once you go down the rabbit hole, you might never come back. So write this down. Similar to finite state machines, you have behavior trees. And behavior trees are also finite state machines actually. The biggest difference is that a finite state machine describes the function, while the behavior tree describes the flow. Behavior trees are more advanced, and without a user interface to set them up and manage them, it might become really messy. Plugins like Opsif Behavior Designer might be worth to invest in. Then there is goal-oriented action planning, which is really cool. That's what they use in the game Fear, which was very innovative at that time. And this is really cool, but very complex as well. And then there is the challenge of having a huge crowd of computer-controlled enemies. In this case, you might want to look at ECS first. That will give you really the high performance that you might need. Finally, fun fact, you can define state machines visually using visual scripting. That's quite interesting. Okay, side note closed. Now, there are many ways to implement a state machine in C#. Should we implement our own? No, let's be highly efficient developers and not reinvent the wheel. Thank you very much, Jason. He writes great code, but I'm sure you know him already. There are just two files. One is an interface and one is a class. You can find the code in the description. Let's just fly over it. The iState is an interface that will be implemented by any state that we will create. And the state machine keeps track of states and transitions. You add a transition by saying, go from this state to this state, if that condition is true. The tick method is what we will call in the update method. It's basically the new update method. And the rest is just boilerplate code to make all work safely. Going back to our enemy, this is what we will do. Our enemy will have more states and naturally appear smarter. First, the enemy will run and find cover. From there, the enemy will shoot at the player. Finally, when he is out of ammo, he will duck and reload. Let's duplicate our enemy, rename the old one stupid and the new one smarter. I will also disable the old one so it doesn't annoy us. For the new enemy, we are going to just do one small change on the NavMesh. The stopping distance will be 0 because we will choose better targets and not just blindly charge the player. and we don't need the old script anymore. Now let's take care of the cover. There are many ways to implement cover. You can go the procedural way or you can go the manual way. That's what we are going to do, the manual way, because it's simple and the goal of this tutorial is not to implement or compute covers. I will create a new game object called covers, and inside I will create another game object called cover. Give it a label and position it behind one of those boxes. Every cover will have a cover script, and that script will just display a gizmo box, nothing fancy. Now unleash your level design skills and duplicate the cover where it makes sense. Last thing is to add a cover area script on the covers game object. This script will find all of its child covers, and we are going to have also one method called getRandomCover. For the moment it will just return a random cover, but you can also imagine using the agent location given as parameter to maybe filter out the cover to only choosing among the 5 closest, for example, something like that. I show you a simple structure, keep it flexible, and you can extend it as you please. Alright, with our new plan, we will also update the animator and learn a few more things. I will duplicate the Cypher Warrior animator that we used and rename the new one to Smarter Tutorial. I know my naming skills are pretty rough today. Then we drag and drop the new one into the animator, and now we can modify it. We keep the movement, but we will delete the other state. Instead, we will have a sub-state machine called combat with a new Boolean parameter called combat. We will use that to transition from movement into combat. Let's double click to open the state machine and let's get to work. Create a new blend tree, call it cover. We can add a transition from cover to base layer, state machine, base layer. So it will go to the entry state of the layer above. And we will transition when combat is false. For the cover, we use a blend tree to easily choose how we want to cover. Instead of having lots of states, we can use a blend tree to choose an animation among several. We basically use the blend tree as a list. So I will add a parameter called cover and use that as a blend. Let's add 2 motion fields. First animation will be idle gun middle, and the second animation will be idle ducking. And you can use the cover value to choose which one we play. Back to the combat state. We can add another state with a shoot burst shot animation. We transition from combat to shoot, has extra time can be turned off, and in the conditions we add the shooting to true. Now as a small variation, we will add a new state called idle shoot with the idle shoot animation. Here we use that to add a delay between burst shots. So add a transition and I just tweaked the exit time to 0.8 and transition duration to 0.2 because it was looking fine. Now in this state we transition back when shooting is still true, otherwise we transition back to cover when shooting is false. We also uncheck has exit time. Okay, you might wonder where is the reload animation? Well, I will show you how you can use layers to overlap or override animations. On the top left, click on layers, and from now we have only one base layer. We can create another layer and name it reload. Every setting here is important. The weight is used to determine how much this layer affects the rig, the mask is used to ignore certain bones, and the blending is used to decide if this layer takes over the previous layers or if it blends additively. If you go to the animations folder, you will see that this asset came with a default avatar mask, which naturally has the full rig enabled. I duplicated it and called it shooting mask, which now I realize might be better called upper body mask, for example, or something like that. Anyway, on that avatar mask, just click on the zones that should be disabled. In this case, I will disable everything below the legs. Then you can reopen the layer settings and set the mask. Reload is a good candidate to be on this layer because you might want to reload in any situation. While running, while crawling, while ducking. So the legs will always be doing something different and the reload animation just should be applied on the hands. Now inside that layer, let's create a new state, put the reload animation in, and right now it's default state, but we don't want that. We will create a new empty state called nothing that will be the default state, and it will literally do nothing most of the time. We will add a transition from any state to reload and from reload to exit. We will use a trigger called reload to run this animation. On the transition, let's set the condition to use that reload trigger. And on the other transition, I will just change the exit time to 0 and the duration to 0.2. And that's really important for the next step, because the next step is to go into the reload animation and add an event. Around 0.8, I added an event that will call the reload function. Now, if the event happens to be at the very end and you have some exit times or transitions times defined, there is a huge risk that the event will not be triggered. You are warned. Alright, we are good in terms of animations. It seemed like a lot, but really it's not. And if you want to see how crazy you can go with animators, I highly recommend that you watch this talk here, where you will get a unique look at the animations of the game Firewatch. They used Unity as well and have lots of valuable lessons to share. Alright, back to our business. We need a new enemy brain script, and we will create a new folder and put all the states that we will write for that. Drag and drop the new enemy brain on the character, take a sip of coffee, and let's implement this bad boy. We need two private variables as usual, the enemy references and a state machine. In the start method, we get the enemy references and create a new state machine. Here we will set up the state machine, but we don't have any states yet. Those two lines are helper functions that make adding transitions shorter and more readable. That's from Jason's video. In the update method, we just do stateMachine.tick, and since each state implements iState, we can get the current gizmo color for that state. That's really good for debugging. The first state that we are going to implement is run to cover. Instead of model behavior, it will implement the iState interface. We have to implement all those methods, or at least define them. Then we need again to have a reference to the enemy references, and we will also have to take a cover area. The state will receive them through a public constructor. The rest of the methods are pretty simple, and you will see that working with state machines actually make your code really easy to work with. On enter is the most important one for this state. When the agent enters the run to cover state, we find cover using the get random cover, and then we tell the NavMesh agent to go there. Get random cover takes the location, even if you don't do anything with it, but maybe that's an idea for the challenge at the end. Just a side note, the state is not a mono behavior, so we don't have direct access to things like transform or even coroutines. Okay, we update our speed using the desired velocity dot square magnitude. And on exit, we set the animation speed back to 0. A little tip, make each state leave as they found the place when they arrived. So you just reset values to the initial or default states, and you will be very thankful to yourself later on. And finally, we can say that this state's gizmo is blue, for example. Now this state is ready. In the enemy brain, we can create a new var, run to cover, and already set it to the starting state. Save, play, and it works. The enemy runs to a random cover position. Every time you start the game, he will run to another one. Let's do more states. Once we arrive at the destination, we will have a cover state. We prepare the code, but this state will basically have a sub-state machine to handle the shooting, ducking, and reloading. For now, we set the references, set the combat parameter of the animator to true on enter and to false on exit. And let's make this state gray since it's not done. What is great with state is that you can naturally reuse them, if you did a good job. I will create another state called delay, which will keep track of a deadline. I will add a new public method called isDone, which will return true when the time passed the deadline. See, states are normally self-contained, but sometimes the state machine needs to talk to one of the states and say like, hey, little state, are you done maybe? Same with the run to cover. Let's add a public method so that we can ask if the agent has arrived at his destination. Alright, we can finalize the state machine now. We create the delay state with a waiting time of 2 seconds, and we create the cover state. Finally, we define the transitions. From run to cover, we go into the delay state. We transition when run to cover dot has arrived at destination is true. From delay, we go into cover state once the delay is done. Let's try it out. The gizmo is blue, it means we run to cover. We wait 2 seconds, the gizmo changes, we enter the cover state, and we can see that the combat flag is set. All good. Next, the shooting state. I think that by now everything should be routine, or at least the routines should start to kick in. We need enemy references and a public constructor. We need the position of the target. So, I don't know how exciting you are getting, but calm down. We are not building a full targeting system. In this tutorial, we do the forbidden find with tag to find the player. In the tick method, we make sure we have a target. If we do, we can copy paste the quaternion code to look at the target. And we simply set the bool shooting of the animator to true. What changes is that we need to use the enemy references.transform. When we exit, we leave the place as is. So we stop the shooting and we forget about the target. And this is a violent state, so it's going to be red. Next up, the reload state. This one is super simple, but we will have to modify the shooter script. As always, get those references. On enter, we could set the cover value to 1 and trigger the reload. When we exit, we put cover back to 0. Gizmo color is gray because I didn't care. Now back into the cover state. This state will have a sub-state machine that we define like this. We create 3 states: enemy shoot, enemy delay, enemy reload. See, we can really easily reuse states. From shoot, we transition to reload when the shooter gives us the green light to reload. From reload, we go into a delay once we are done reloading. For that, we can use the negation. And from delay, we go back into shooting once the delay is done. Last detail is missing, and it is to do a state machine.tick in the tick and return the sub-state machine gizmo color. At this point, you will have some compilation errors because some things are missing. First, let's add the shooter in the enemy references script. Next, let's implement some ammo in the shooter script. Public int ammo starts at 30 and private int current ammo to track it. We add 2 public methods, public bool should reload, that returns true if the current ammo is 0 or less, and public void reload that will refill the ammo. Then we can reload once we are in the awake method to be sure that we have some ammo ready. And in the shoot method, we can put a guard that will directly return if we should reload, so no shooting. Last detail is to reduce the current ammo by 1 every time we shoot. And you know what? We are done, we are ready. Save everything, runs the game. The enemy runs to cover, shoots like a stormtrooper, and reloads every 10 bursts, since 1 burst shoots 3 bullets. Now, wait before you leave. If you made it this far, that's awesome. And it shows dedication. You might have seen my announcement video where I talk about the GameDev Kingdom, a new community for game developers and artists to learn together and grow like crazy. Well, it has launched with this first video of a long series of tutorials. The link to the Discord server is in the description and I really hope to see you there. I have no idea how it's going to be in the beginning. There might be lots of people, there might be no one. In any case, I will be there to support and discuss things. And for the challenges, all the details will be given in the Discord server. With that being said, I thank you very much for watching. I hope you learned something and have now a good base to create smarter enemies and smarter AI. Now go work on your game and I'll see you next time. That was a long video. I think it was long because of the animation stuff. All the animators, animations, transitions between states, that takes really a lot of time. And there is still so much more that can be done there. It's crazy, so yeah. But it's cool, it's fun.